equations. Okay, so DE, so this is the shortcut for differential equation. So it is defined as an equation or equations that contains differentials. Okay, so differential equation or DE is defined as an equation or equations that contains differentials. So if we say equation, so for example we have an equation here, x plus y is equal to 0, so that is an equation. So this is a basic equation. This is a linear equation. Okay, linear equation. You can also have sine x plus sine y is equal to, maybe we'll have here 2. So this is a trigonometric okay, trigonometric equation. Then we can have also ln x plus ln y is equal to 7. So this is a logarithmic equation. So during your previous math subjects, so you have encountered these 3 equations, so 3 most common types of equations. So maybe on your basic engineering mathematics, you have encountered these 3 equations. So in DE, we will introduce a new equation, which is the differential equation. So we'll have an example of a DE here. So we have dy dx is equal to cosine x. So this is now an example of a differential equation. Okay, so we can also have a more complex example. So we will have d squared y dx squared, or the proper naming of this one is the second degree derivative of y in terms of x plus k squared y is equal to 0. So this is another example of a differential equation. Then we can also have this one. So we have x squared plus y squared dy minus 2xy dx is equal to 0. So this is another example of a differential equation. Okay. So going back to your differential calculus, because the notion or the concept of differential comes from derivatives or differential equation, differential calculus. So we have the so-called order of a derivative or differentials. Okay, so for example, we have a differential dy. We will use another color. So we will be using pink for how many lines now of discussion. So we have dy dx, or we could also call this one as y prime. So this is a first order derivative. Then we have also d squared y dx, okay, or we have that one double prime. So the again, the proper nomenclature of this one is the second derivative of y in terms of x. So this is a second order derivative. Okay, then we have third order derivative, or the third derivative of y in terms of x. Then this is also y double prime. So this is a third order derivative. So fourth, fifth up to the nth, so we just have that this is the nth order derivative of y in terms of x, or we can have this one as y to the n. So this is the nth order derivative. So this is just a review of your differential calculus. So this is how we get the order of a derivative. Okay, now we will use this concept in getting the order and the degree. We'll use another color, green. So the order and the degree of the differential equation. Okay, so for the degree of our DE, this is order, just first discuss the order. The order of our differential equation, so this is the order of the highest order derivative present in the equation. So for example, we have this differential equation, d squared, or the second order derivative of y in terms of x, plus dy dx is equal to 2x. Okay, so if you are going to get the order of this differential equation, so we need to first to analyze each of the terms. So in this equation, we have three terms. So this is our first term, second, and our third. Okay, so in the first term, the order of the derivative is second. On the second term, the order of the derivative is first. So that's why we don't have any indication here that is that or any number here, or this superscript. Then for the third term, so it has no derivative or differential, so this is a constant. Okay, so our highest order derivative is in the second order. So therefore, this DE is a second order differential equation. So we base our order of the differential equation on the highest order derivative present on the differential equation, in which in this example, the highest order derivative is on the first term, which is on the second order. So that's why the order of our differential equation is second. Okay, now we go to degree of the differential equation. Okay, so for example, we have the definition. So the degree of the differential equation is the degree, or we call that one as the exponent of the highest order derivative on the equation. Okay. So the definition of the degree of a differential equation is the degree of the dE is the degree or exponent of the highest order derivative on the equation. Okay. So example. So we have this example. D squared x dy, so squared, so second order derivative, plus dy dx is equal to 3x. Okay, so this is our, okay, so we'll put here the exponent, then this one. Okay, so this is 3x squared. So this is now our given differential equation. So again, we have three terms for this differential equation. This is the first, okay, this is the first, the second, and the third. Okay, the order for the first term is second, so this is the indication that the order is second. So this superscript here. Then for the second term, so it is on the first order. Then on the third term, this is constant. So the degree now, or the exponent for each of the term. So for the first term, so it is second, so second degree. For the second order, second term, this is third, and this is third. So our exponent is squared, so this is second. Okay, so the degree now of our differential equation is based on the highest order derivative. So our highest order derivative is this term, the first term, which is the second order. So whatever the degree of that term, that is also the degree of our differential equation. And in this example, it is on the second degree. So our dE is a second degree differential equation. So the highest degree for the terms in these three terms is 3, which is on the first, which is on the second term. But the order of our second term is on the first. So the second term is not the highest degree derivative, the highest order derivative. So we will not consider the degree of that term. So in this example, the highest order derivative is in the first term, and its degree is second. That's why our degree for this example is on the second degree. So if you have any questions so far, so you could chat on our chat box or on our group chat. Okay, before we will proceed to the next definitions. Okay, so I believe there is no questions. Okay, so we will now go to the next definitions, or the next few definitions. Okay. So the few definitions now is, the next is we will go to the general solution. Okay, so the general solution is the solution of a differential equation which has arbitrary constants. Okay, so of course we are tackling with equations, so therefore every equation has a solution. So for our differential equation, differential equation, the solution of a differential equation could be first a general solution. So for example, if we have this solution, y is equal to c1 e to the x plus c2 e to the 3x. So this is an example of a general solution, because in this example, or in this solution, we have the so-called arbitrary constant. So these two are the arbitrary constants. Okay. Then we have also the other type of solution, which is the particular solution. So the particular solution is a solution of a differential equation which has no arbitrary constants. Okay, so example of this one is, we will have the same solution but as given above, but we will just delete or have a exact number for the arbitrary constant. Okay, so we have 2e to the 3x plus 4e to the 2x. So in this equation, we don't have any arbitrary constant, which is c1, c2, c3, etc., etc. So this is now what we call as a particular solution. Okay, so that is now the definition of general and particular solution. Then we will go also to the concept of okay, the concept, we will just move it down. Concept of arbitrary constants. Okay, so example, we have in your integral, usually, for example, the integral of x squared dx, so it is equal to, this will be x cubed over 3 plus c. So this c here, this is now in arbitrary constant. So in your integral, the c could only be omitted on the solution if the given integral has its limits. So for example, from 3 to 0, or from 0 to 3. Okay, so I believe nga na we have the Wi-Fi have resetted, so maybe I don't know asa dapit ko nahuman or asa dapit nag-end, but I believe on the discussion, so we ended on this part, okay, the concept of arbitrary constant. So This is on your integral calculus. So again, this is a indefinite integral. That's why we have an arbitrary constant, and this is a definite integral. That's why we don't have any arbitrary constant. Now, on the concept of arbitrary constant, so if you have two constants, you add the two constants together, the answer is still a constant, because, for example, your first constant is 1 and your second constant is 2. So 1 plus 2, that will be 3, and still that is a constant. Then also a constant minus a constant is still a constant. So we have 1 minus 2, that is negative 1. So 1 is a constant, negative 2 is a constant, and the answer negative 1 is still a constant. So C times C, or a constant times a constant, is still a constant. So 2 times 3 equals to 6. So these three numbers here are constants, and a constant divided by a constant is still a constant, because the quotient of that is another constant. So that is the discussion, on which I believe was not a stream or live stream by YouTube, because we have disconnected on our live stream. So also, for you who have not able to finish or view this discussion from the start, so you could backtrack the live stream, and also I will be posting a copy of this discussion on our Google Classroom. And later tonight, I will be sending a assignment for you to answer, and for you to answer before or submit before the next meeting, which is Monday 7 p.m. So the assignment is just about the order and the degree of the differential equation. So next meeting, we'll be discussing about elimination of arbitrary constant, and also everything written on this screen. I will also be sending the PDF copy of this one in our Google Classroom later tonight. So if you have any questions, then maybe you could just put that one, your questions, on our chat. So in the chat box or in the group chat. So I'll be waiting for your questions.